Vapour Pressure Lowering. This is a question taken from one of the lecture slides from Olungushi University, and the question reads: Glycerine or glycerine, which is the chemical formula C3H8O3, is a non-volatile liquid with a density of 1.26 grams per milliliter. Calculate the vapor pressure at 25 degrees Celsius of a solution made by adding 50 milliliter glycerine to 500 milliliter of water. The vapor pressure of pure water at 25 degrees Celsius. Okay, sorry, the question was not copied properly. It's supposed to be at 25 degrees Celsius. A Celsius was left, is 23.8 torr. This is the vapor pressure. So this question we need to understand, and for this question it's easy. They've told us already that this glycerine, it's a non-volatile liquid. Therefore, the formula we'll use is equal to the vapor pressure of the solution is equal to the pure pressure or the pure vapor pressure of a solvent, which is abbreviated P to the power O, pure vapor pressure of a solvent, multiplied by the mole fraction of the solvent. This is the formula we use when the solute which has been added to a solvent is non-volatile. So this is the formula we use. So from the data we have density of the glycerine, which is 1.26 grams per mole. Then the volume of glycerine is 5 milliliter. Then volume of water is 500 milliliter. Then density of water is 1.0 grams per milliliter. This is we assume that since it's not given, since the density of water is not given in our question, the statement in the question, since it's not given, so we assume that the density of water is 1.0 grams per milliliter at 25 degrees Celsius. Then the vapor pressure of the pure vapor pressure of water is 23.8 torr. So from this we can now come up with the formula of the mole fraction of the solvent. So we abbreviate our solvent to be N1, or our solvent to be X1. So the number of moles of our solvent, will abbreviate them to be N1. Then the number of moles of our solute, will abbreviate it as N2. Therefore, this is the equation. The mole fraction of the solvent is equal to N1 divided by the sum of the number of moles of solute plus number of moles of the solvent. So we continue with our question. So the first thing we'll do is to calculate the mass, or to calculate the mass, as we want to calculate the number of moles of glycerine. So we continue. So we have to find the mass. So here, this is the formula. Once we plug in, then that's the formula we should use. So we calculate the mass now of the glycerine. So we plug in density is equal to mass over volume. So the density of 1.26 grams per liter, we plug in there. Then the mass, then also plug in the volume. So we realize that the mass of the glycerine is after multiplying is giving us 63 grams. So that's the mass for the glycerine. So now we go to calculating the number of moles of glycerine. So as we continue. Okay, so we know the formula for calculating the number of moles. So number of moles is equal to mass over molar mass. So what is the mass of glycerin? It's the one from calculating 63 grams. We plug in. Then what is the molar mass for glycerin? When you calculate, you find that the molar mass of glycerin is 92 grams per mole. Then after dividing the number of moles, we find that it's 0.685. So the number of moles of glycerin is approximately to 0.685. So we continue now to calculating the number of moles of water. So we continue. We now have to calculate the number of moles of water. So density is equal to the mass over volume. So the density of water will assume it's 1 grams per milliliter. Then what is the mass? The mass is the one we are calculating. So we have the volume of 500 milliliter. So the mass of water is 500 grams. So we now introduce the formula. Number of moles is equal to mass over molar mass. What is the mass? Mass is the 500 grams. What is the molar mass of water? It's approximately 18 grams per mole. So when we calculate, we find that the number of moles of water is equal to 27.78 moles. So this is the number of moles of water. So to calculate now the mole fraction of water, which is a solvent. So we'll say so the mole fraction of water is equal to Ni over Ni plus N2. So these are just symbols I've introduced to represent the moles of water and the moles of glycerine. We continue. So we now have to calculate the mole fraction. We continue with calculating the mole fraction. So now we substitute N1 is equal to 27.7, then N2 is equal to 0.685. So we substitute. When we substitute in our equation, we find that the mole fraction of N1, which is water. By the way, N1 is representing water in this case. So the mole fraction is equal to 0.976. So now we have the mole fraction, and from our equation it is given that the vapor pressure of solution is equal to the pure vapor pressure of a solvent multiplied by the mole fraction of solvent. The mole fraction of solvent. So that's what our equation says. So from here we can substitute. What is our vapor pressure of the pure vapor pressure of our solvent? It's 23.80. So multiplied by what is the mole fraction is 0.9 what? We found that is 0.976. that is our mole fraction of water. So we continue. When we multiply that, we find that the vapor pressure of the solution is equal to 23.229 torr, because these are the units we are dealing with for pressure. So this is the vapor pressure of the solution. So this shows that whenever a solute is added in a solvent, there is always a drop in the vapor pressure. So we can calculate the vapor pressure lowering by subtracting the vapor pressure of the solution from the vapor or from the pure vapor pressure of the solvent. So we say the vapor pressure lowering is equal to this, okay, which in this case will be 23.8 minus 23.23. So we realize that the vapor pressure lowering in this case is the vapor pressure lowering in this case is 0.571 torr. So this is the vapor pressure lowering in this case. So this is what we are expected to do in this question. Thank you for watching this video. Remember to subscribe to my YouTube channel so that you continue supporting me. Remember to subscribe to my YouTube channel so that you continue supporting me.